Welcome back to the shop. This evening I'm going to get started on a project I've put off for a few weeks now, and that is to machine a new Boring Bar Grinding Jig. The jig I've been using for the last several years was made of aluminum, and I've just kind of completely worn it out, so I've tossed it a couple weeks ago, and now I need to make a new one. In my shop, I predominantly use this style of cheap import high-speed steel bar because they're really easy to grind. I do have some solid carbide bars and then some insert tooling bars, but the insert bars are not that great. They came as part of a kit and they don't work that well. The solid carbide bars I have are from Micro 100 and they're excellent, but I don't have a really good method of sharpening them because I don't have a carbide grinder right now. So I kind of use those sparingly as well. So for the vast majority of my work, these are what I use to get the job done. And they work perfectly well. Let me put them aside here. So there's really only one issue with this style of bar, in my opinion, and that's if you're using like a grinding rest like I do on my grinder, because some people can do it, perfectly by hand. They can just grind everything by feel. I can't do that. It's not me. I don't do it often enough. So I rely heavily on my rest. And that's a problem with this style of bar because there's no flats on it. Here's a 3/8 high-speed steel tool blank. I think this is that's a Momax. If I'm grinding on it, I've got it down on the tool rest. I've got this nice flat reference surface to work from, so I can grind an edge, go and dip it in the water, cool it off, bring it back, and sit it right down, and I've got that perfect reference surface again. You can't do that with a perfectly cylindrical boring bar like this. So when you're grinding, you get that nice facet going, and then you dip it, you come back, and if you're doing it by hand, chances are you're not going to get the same facet that you had previously. So that's why for a while now, I've been using a grinding fixture, or a grinding jig. And really all it is in this case, this is the new one I'm going to machine tonight, is a block of steel that's 1 1/8 inches by 1 1/8 inches by 2 inches long. Has a hole bored through it for the bars to actually sit in, and then some holes drilled and tapped for set screws that'll actually hold the bar in place. So the benefit of this is, let's take this bar here, for example. Once you've locked it in place, you now have 4 reference surfaces: bottom, left side, right side, and then the top surface. So you can lock it in place and you can grind away. When the bit starts getting hot, you can dip it, come back. When you sit it down on that rest, it's going to be exactly how you had it before. And what that allows you to do is a couple things. So for example, here's 3 bits that I grabbed that are all a little different. This is one I grabbed and I machined it a while ago. I can't remember what I did it for, but I needed to get a hole bored into a really small hole. It was fairly long and pretty small. So as you can see, I had to grind on almost all the faces to get it thinned down to get it in the hole. That was really easy to do, to lock it in the block. Just lock it in, grind this side, grind that side, flip it 90 degrees, grind the top, done. If you've seen any of my previous videos, this is what I use quite a bit. This is a bit that I've ground specifically for chamfering really big holes over at the mill on the boring head. So, and the block I had previously, I just locked it in place, rough ground it, get it close to 45 degrees. Then I just put a reference edge down, clamped a piece of steel down to my stop, set the block down, slid it up against the edge, and then just pushed it in until I got a nice clean facet all the way along the edge. And this one is another good example where it helps to have a nice big flat reference surface. If you saw the video where I did an upgrade for my quick change tool post and I needed to machine the top of the compound base, I machined it perfectly, a big one solid continuous facet across the front. Then I rotated the bit and the holder perfectly perpendicular to the grinding wheel and went in and just made a little flat. You might be able to see it here. That's, a 1/16 of an inch wide. And the reason for that being is that I needed to get the bottom of the bore perfectly flat. So what I did is I came down and would let it dwell. And I'd go up and I'd move the bit, the boring head, open it up a little bit and go out and come down, out, come down, out, come down, to make the bottom of the bore perfectly flat. But that would be really hard to do, to get it perfectly perpendicular to the axis of the boring bar, and then hold the appropriate angle so you're not tilting it this way or that way. Well, not if you weren't using a rest. So I've really come to rely on the grinding rest and on various jigs for grinding tools. So let me show you. The issue I'm going to face, the first issue is, like I said, this is only 1.125 by 1.125 by 2 inches long. And the only stock I have on hand is this, which is a chunk of 1018 that's 2 by 2. So I've got to remove quite a bit. I think I figured out how I'm going to do this quickly. Let's go over to the bandsaw and I'll show you what I got. I've mounted the workpiece here in the bandsaw, and then since I'm grabbing such a narrow section of it, I have to have a piece of scrap bar stock back here plus some feeler gauges to shim it out to the right thickness so that the free moving jaw here on the vise doesn't cock. And then to validate that the bar stock is square to the fence, just use the regular old, in this case, this is a square I have for woodworking and for metalworking with a nice fence on it. Let me go ahead and I'll bandsaw this large chunk off, and then we'll head over to the mill. The bandsaw face is cleaned up, and now I'm going to go back and remove the remaining thickness to bring the stock down to dimension in this direction on the stock mill face. So this is the final pass, and then it's back to the bandsaw. I've got the other end faced off, and now I'm going to face off this end and bring it down to size. 35,000 still to come off. Okay, final pass, 2/1000. And just to try and make this as clean as possible, I've added an extra 0.5 to do in a climb cut. And that's it for the milling. All I have to do is take this over to the bench, deburr it, and then I'll be ready to drill some holes. Oh, I caught a mistake. The carbide bar that I grabbed had the wrong size shank, so I would have been fairly annoyed if I had done all the work and gone to start the boring and realized, oh crap, this is the wrong size. However, I do have this high-speed steel one that I've already ground, that if I open up this hole a little bit wider, this should work. So let me open this up and I'll do the chamfering. That definitely looks to be the right size or even a little over, so that's good. Now I can flip this around, lay it down its side, and drill the threaded holes for the set screws. Nothing spectacular here, just a little tap magic. Help with the tapping. This is such a fine thread that doesn't require much force. Threads look good. On to the next two. So I've got you in nice and tight here, so hopefully you can see down in the bore pretty well. As I mentioned previously, I started off with one of these cheap import high-speed steel bits, and it did okay. But it left a really bad surface finish in the bore itself, mainly because it's got 4 interrupted cuts to deal with. It's got 4 holes that generate interrupted cuts. So since now that I've got the hole large enough in diameter, I've switched over to my solid carbide bar, which you can see here. And the surface finish is better down in there, but it's not as good as it could be. So hopefully I'll get a little more dialed in. I've been playing with feed and speed and depth of cut and everything. And I'm getting okay. I'm not happy with it, but I'm not like horribly displeased with it either. So I'll show you guys what we get here. As you can see, the finish down the bore is not that bad. It could be better. I'm going to try one other thing here, and that's to crank my machine all the way up to maximum RPM. I mean, it's only a 1/2-inch diameter hole. This is a solid carbide, so I can't overwhelm it. I can't burn up the end of the boring bar. I just simply can't spin it fast enough for that. But we'll see how if the head shakes or anything like that. At 1100 RPMs, it's been perfectly fine because as you can't really see, but I'm maybe 30 thousandths off perfectly aligned for the boring head, so it's not really generating a lot of inertia to throw it out of balance. So let me move the camera out of the way, and I'll finish this off, and then I'll bring you back and show you what I got at the end. So I was shooting for 0.5 to 0.503, and I'm about 0.5005, so 5/10 over the minimum, which will give me a little leeway. I'm probably going to take this out now. I might try and hone the inside a little bit just for my own ridiculousness, but I'll bring you back once I get ready to do the last bit of machining, which is to chamfer everything. So I've got everything set up, and it's now time to do the final operation, which is to chamfer all the edges. Bring the chamfering tool down pretty close, lock the quill down, and then I'll feed in to get to the right amount of chamfer that I want. The nice part about this being perfectly square is I can just keep rotating everything. I don't have to change any of the settings on the quill or anything like that. Just make sure the part's pushed down against the parallels. Okay, this will be the last edge. And that is it for all the machining. Chamfers look pretty good. I'm going to go over and clean this up. I still have to take a file and just knock off the corners just so those aren't super sharp. So off camera, I went ahead and lapped the surfaces real quick, and then I tried rust bluing one more time to see if I could get better results. And I did get substantially better results than the first time. It's still a little splotchy, and it's got a little pitted. I think the concentration I was using was a little too strong, but overall I'm kind of pleased with the finish so far. I mean, it's not going to hold up over at the grinder because, you know, you're just going to get grinding grit underneath the surfaces and it's just going to remove it all, but it was just an experiment. So let me take you over to the grinder and I'll show you how to use this. And there you go. The angles aren't anything specific, but that's 3 surfaces that are nice and continuous. It will be really easy to lap. So that's it for this project.